Okay, so our lesson we talked about today was over zero pairs. So our official definition of a zero pair is a pair of numbers when added together equal zero. So we talked a lot about earlier this week about positive and negative numbers. So what this means is I can take one positive and one negative, and when I add those two together, it's like they cancel each other out and we get a value of zero. So one positive, one negative, add them together and you get a value of zero. That is our official definition of a zero pair. So our notes today were all about just figuring out what is the value of the tiles shown. So I'm going to start with set one. And when I look at set one and all of our sets, remember that all of the shaded tiles represent our negative integers and the positive tiles are represented by the unshaded integers. So when I see a set like this, the first thing I want to do is I want to create any zero pairs. Let's get rid of things that are going to add up to become zero. So I'm going to cross off one positive tile, one negative tile, one positive tile, one negative tile, one positive tile, one negative tile. So I've created 3 sets of zero pairs. And whatever I have left over, that is the value of that set. So I only have 2 unshaded tiles left. So the value of this is just positive 2 or 2. Going on to set 2, I'm going to cross off all my zero pairs. So again, zero pairs are made up of one positive, one negative. And when I make all my zero pairs, there were 3 sets of zero pairs to make, and I have nothing left over. Everything was part of a zero pair. So set 2 has a value of 0. Set 3, I'm going to do the same thing, cross off all my zero pairs. So there's one set, another set, and a last set. So I made 3 sets of zero pairs, and I have 1, 2, 3 shaded tiles left for a value of -3. Set 4, I'm going to cross off all my zero pairs. This time I had 4 sets of zero pairs, and I have 4 unshaded tiles left for a value of 4, positive 4. All right, looking at our next one, problem number 1. When I look here, it changed shape, but this unshaded still represents positive, shaded still represents negative. When I look here, I don't have any zero pairs to make. I have only negative tiles. So I just need to count how many for the value. So there's 1, 2, 3, 4, 5, 6, 7. This one has a value of -7. This time our model is actually in the shape of positives and negatives. So I'm going to make zero pairs because I see that I've got a combination of both. I had 2 sets of zero pairs and it left me with a value of +4 or just 4. Number 3, I see that I can make zero pairs because I've got positives and negatives. So cross off a positive and a negative. So there's 4 sets so far. So I can make 8 sets of zero pairs there, but the only thing I'm left with is -2. And then on problem number 4, I only see positive tiles. I don't have any negatives, so there are no zero pairs to make here. So I just need to count how many positive tiles I see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be 12 or +12. Okay, so now we're going to look at how do we add and subtract with these negative tiles and these positive tiles. So we're going to start with our model, then we're going to do whatever the prompt tells us to do, and then talk about its value. So when I look at this model, my model currently has a value of +5. I have 5 unshaded tiles. And my prompt says to add 5 negatives. So I'm going to add 1, 2, 3, 4, 5. And after I've done the prompt, I'm going to see, are there any zero pairs that I can make? So there's a zero pair. So sure enough, I had 5 sets of zero pairs to make. I crossed out every single tile, so this has a value of 0. When I look at my next model, it currently has a value of -9, and the prompt says to just take away 2 negatives, get rid of them. So there goes 1, 2. So when I get rid of those 2 negatives, my new value is -7. My third problem has a value of -3, but my prompt says to add 4 positives. So there's 1, 2, 3, and 4. So let's make zero pairs. So there's 1 set, 2 sets, 3 sets. and all I have left over is a positive 1. Our next problem has a current value of positive 4, but my problem says to take away 7 negatives. But when I look, I don't have any negative tiles to take away. So I have to somehow put negative 7 tiles here without changing the value of the problem in order for me to take them away. This is where our zero pairs come in handy. So remember, if I have a positive and a negative, together they add 0 value. So in order to take away 7 negatives, I have to have 7 negatives there. And the way to do it is to add 7 sets of zero pairs. So I'm going to start with my positives. 4, 5, 6, 7. I'm going to put my negatives right below it. So what I'm doing again is I am adding 7 sets of zero pairs because now these technically have no value. They would all cancel each other out. But now I have 7 negative tiles that I am able to take away. So if I take away those 7 negative tiles, I am left with 4 plus 7, which would be 11 positive tiles. So this one has a value of positive 11. Our next one says to add 3 zero pairs. So there's 1, 2, 3. Remember, zero pairs add no value. They cancel each other out. So this one still just has a value of 1. Our next one says to add 6 negatives. So there's 1, 2, 3, 4, 5, 6. So it started with a value of negative 2. I added 6 more negatives to it for a value of negative 8. This one says to take away 3 negatives, but my current value is positive 3. So again, I have no negatives to take away. So I have to be able to add some negatives there without changing the value, and that's going to be by adding 3 zero pairs. So now I have 3 negatives I can take away, which gives me a value of 6. And last but not least, adding 8 negatives. This would be 1, 2, 3, 4, 5, 6, 7, 8. And I have some zero pairs that I can make here. So there would be 1 set, 2 sets, which leaves me with 1, 2, 3, 4, 5, 6 negative tiles. So a value of negative 6.